some of you may have been looking at the picture, and does anybody have any guesses as to what scene is being depicted there? No? Really? I mean, not at all. I guess it. Okay, this is the quarrel of Oberon and Titania from Shakespeare's A Midsummer Night's Dream, and it's painted by the Scottish artist Noel Pattern. And Charles Dodson, who's more popular by his pseudonym Lewis Carroll, once counted 165 fairies in the picture, each involved in their own story. So when I first told people that I want to give a non-technical talk about my research area and talk about the people involved in the work, they were like, well, what can you talk about? And who wants to hear anyway? And there seems to be an implicit assumption that the life of an artist, is enriched with beauty and color and passion and things like that, but that scientists conduct their lives with the same objective and analytic principles that they apply to their research. And of course, I'm going to try and tell you the story of a research area, but in such a story, it will be the research areas that dominate the foreground. But like in the painting, the story would be abysmally impoverished if not for a large array of characters all over the place, each involved in their own comic, passionate, sometimes even sinister or morbid story. And I hope to convey some of that to you. So the chronicle of a research area, to me, is a bit like, say, the periods in Greek mythology. In the beginning, you have the Age of Gods, where these people come along, and out of thin air, you have an entire research area suddenly created. But also, everybody seems to know everybody else. Everybody fights with everybody else, and things like that. And then you have the Age of Heroes, where you have the descendants of the gods, and all the problems have been defined, but some young person comes along and works very hard for a very long time and overcomes this really unbelievably hard problem and amazes everyone. And then finally, you have the Age of Men, where I guess research is to some extent closely connected with drinking coffee. Yeah. So I will be telling you the story of the history of verification, but I hope just to tell you where this story begins, and it's set in the Age of Heroes, actually, what I think is our Age of Heroes. But I will try to give you a brief glimpse of what I thought was the Age of Gods. Computer science has this tandem development alternating between logic and engineering. So hopefully the history of computer science in 5 minutes. On the logical side, the modern history of logic to some extent begins with the work of George Boole, who in 1854 wrote this monumental treatise called An Investigation into the Laws of Thought. And he argued that the reasoning that mathematicians used could be represented by symbol manipulation in some algebra. His work was significantly extended by Gottlob Frege, who wrote his Begriffsschrift, and he conceived much of logic as we use it today, with predicates, variables, quantification, and even some form of induction. Bertrand Russell, he was a bit of an English polymath. He built on Frege's work and first found a paradox in set theory. And later, this caused a lot of concern about the consistency in mathematics and caused what is called the foundational crisis in mathematics. Then with Alfred North Whitehead, he embarked on this extremely ambitious project to formalize all of mathematics and make it watertight. And to give you some idea of how ambitious and difficult this is, I have a copy of the Principia here. And you can see that it took them about 360 pages to conclude something like 1 + 1 is 2. But this is something necessary if you're trying to do absolute formal mathematics. And I'm not trying to put their work down. It set the stage for Gödel, who would then analyze this system and show that there are statements you can make within the Principia that you cannot prove in the system of the Principia. And this was a bit of a shock for the mathematical world as well, because it showed that proof and truth are not the same notion, even within mathematics. And finally, sort of the nail on the coffin in this whole foundational story was laid by Alan Turing, who came up with the Turing machine model and showed that there are problems which do not have algorithmic solutions. So this is what the logicians were doing at the time. And, well, their personal stories have a lot of the elements of a great Greek tragedy. George Boole was a university professor, but he died fairly young, and he left his family impoverished, so his children didn't even receive a high school education. Gottlob Frege was very introverted by nature, but after Russell discovered a paradox in his work and the death of his wife, he became extremely depressed and gave up research altogether. If you look at his diaries in his later years, he became extremely anti-Semitic. He hated the German unification, he hated the Catholics, he hated the French, he hated pretty much everything around him. Bertrand Russell lived in a fear of mental illness because there was a streak running in his family. His son was diagnosed with schizophrenia, which led to the breakdown of his first marriage, and 2 of his granddaughters were schizophrenic as well. Kurt Gödel was extremely paranoid about being poisoned. He would only eat food if his wife tasted it first. And once his wife was hospitalized for 6 months, and when they finally found him, he weighed about 30 kilos because he starved himself to death in that period. And finally, Alan Turing was a homosexual, and when this was discovered in the climate in Great Britain at that time, it was not very friendly. He was forced to undergo a process of chemical castration, which ended up with him, getting depressed, growing breasts, and things like that. And he eventually died of cyanide poisoning, and it is believed that he committed suicide. So I'm not telling you this to bring you here on a Monday morning and depress you completely and tell you, don't study logic. It's more to somehow show that there is a great pathos in the lives of these people, and there is much more than the dry mathematical results that they're often known for. But if you want something more optimistic, I would say you could look at the lives of the engineers. So very briefly, Leibniz, way back in the 17th century, already invented all the laws of binary multiplication and things like that, and even built a multiplication device. Charles Babbage was a bit, I guess today he would be called obsessive compulsive, okay? He had to be extremely tidy and everything had to be proper, and he couldn't tolerate any error, which is why he believed that all calculations should be done by machine, and he invented a series of difference engines. Konrad Zuse in Berlin conceived what we believe are the first modern programmable computers. They were not Turing complete, but you had the sequence from the Z1 to the Z4. Then Eckert and Mauchly, working for the United States Defense, came up with what we know today as the von Neumann architecture. And Morris Wilks in Cambridge created the EDSAC, which we consider to be the first fully modern Turing-complete programmable microprocessor system. And well, their stories, I think, are a bit nicer. They usually ended up with some amount of money, and it all went fairly well. So that's the history of computing in about 7 minutes, as I could capture it.